Hey everybody, we're going to talk about two different functions today. We're going to talk about our square root functions, and then we're going to also talk about our cube root functions and basically how we graph them. And we're going to talk about the most simple graphs first, and then how we can shift them, stretch them, translate them, and all that to get variations of these basic graphs. So let's start off with our square root function. This is going to be the simplest probably of the two. So the original square root function, we call that the parent function, is f of x equals the square root of x. Okay, so if I asked you to graph this, what I would go ahead and do first is just make a little table of values. And let's say I have my x's and then my f of x. Remember, f of x is the same as y. And I pick 0, 1, and 4. Now the reason I'm picking 0, 1, and 4 is because those are perfect squares. So when we plug them into the square root function, they're going to reduce nicely. Now of course you can always pick other numbers, you're just going to get decimal answers. So I would stick with these to start, but you can use other numbers if you need to, or if you choose to. So when I plug in the square root of 0, I get 0. When I plug in the square root of 1, I get 1. And when I plug the square root of 4, I get 2. Okay, so that should be pretty easy. You're just plugging in numbers. So we're going to go ahead and plot these on our graph. And if you would like graph paper, for this section there's graph paper at the front of the room. Feel free to use it. So we're going to go ahead and plot our first point 0, 0. Then we're going to plot our second point 1, 1. And then 4, 2. So 1, 2, 3, 4, 1, 2. Okay, so here's our graph, and then of course we would curve it up like this, and it keeps going. So when we're looking at this function, this is the most basic function, square root function, we have two things we also want to be able to recognize, and that's the domain and range. So domain is where what x's work for the problem. So remember, we want to look at this, we want to think what's the lowest x can be and what's the highest x can be. Well, the farthest to the left that x goes, remember x is on the horizontal, is 0. Okay, and it does hit 0, so it can be equal to, and then it goes on forever to the right, so I could keep going and going and going, so that's to infinity. And remember, if we have an infinity there, we don't need to write that, so really x is just greater than or equal to 0. Okay, and then we're going to do the same thing for our range. Remember, range is the y's, so I'll put this as x's, this is y. Okay, what's the lowest the y value can go? Well, the lowest it's ever going to go in this case is 0, and it hits 0, so we'll say it's equal. And then it keeps going up forever. It'll be slowly going up, but it does. So this is another infinity. And remember, if we have infinity, we don't write it. So y is greater than or equal to 0. All right, so there's our domain and range. So now let's look at if we have some things that change this function. So let's look at the general case. If we have f of x equals a times the absolute value, or sorry, a times the square root of x. Well, what does this a do? Well, just in general, this is telling us how it's stretched. So if I have the example, f of x equals 3 times the square root of x, let's look at our table of x's and y's. Well, if I plug in my same x's, so 1, or 0, 1, and 4, let's see what happens. I'd have 3 times the square root of 0, which is just 3 times 0, so that's 0. Then I would have 3 times the square root of 1. Well, that's 3 times 1, which is 3. And then 3 times the square root of 4. Square root of 4 is 2, so 3 times 2 is 6. Okay. So what this is doing from the original function is multiplying all my y answers by 3. So if we go to, and I just pulled this up on Desmos, so here's my original function that we just graphed. That's the parent function when a is 1. If I change this to my a is 3 like I had, notice how much that jumps up. So this is getting stretched vertically going all the way up. And the same thing would be happening if I had a 2 or a 4 or an 8. And notice that the little higher up it goes, the more stretched it gets. And if it's negative, it still gets stretched. Okay, but it goes the other way, so it's going down. So you have to be careful of that. Okay. Now, if my example is less than 1, okay, so maybe f of x is equal to half of the square root of x. Now let's see what happens to our table. If I plug in 0, 1, and 4, well, what should happen is the same thing. I should have half of the square root of 0, which is 0, half of the square root of 1, which gets you 1/2, and then half of the square root of 4, which is 1/2 times 2, which is 1. So the rule is, and notice these are all half of the original values that we had in the parent function. So our basic rules is if the absolute value of a is greater than 1, it's a stretch, and I guess I should just say it's a stretch, okay? Well, I'll say vertical, that's fine, vertical stretch. But if the absolute value of a is less than 1, so if it's a decimal, like a fraction, half, 3/4, then it's a vertical shrink. So it's going to get smaller. So notice when I go back to Desmos, if I have a is 0.4, see how this red line is way smaller, it goes down closer to the x-axis than it did when my a value was larger than 1. Okay, so that's our vertical and vertical shrink and stretch. Now the next things we need to do are look at horizontal and vertical translations. So let's say I have f of x equals the square root of x minus h. Well, you guys have kind of seen this before. This h right here is going to tell us the horizontal shift. Okay, so horizontal shift. And I'm just going to do some basic examples. So if I have f of x equals the square root of x minus 2, notice this is underneath the square root, then this means that I'm going to shift right 2. So when it's negative here, it goes to the right. When it's positive, it goes to the left. So I can write that. Negative to the right, and then positive means to the left. Okay, so it's backwards. So if I want to look at Desmos, what that would look like, maybe I have my original green function, so ignore this there, and I have underneath there plus 4. Well, notice that my original function now starts at way at -4, 0, instead of 0, 0. Or if I have minus 2, instead of starting at 0, 0, it starts at 2, 0. So it goes to the right because it was negative. Okay? And the same concept applies with shifting if we have something on the outside of our square root. We call that k. So if k is, this is our vertical shift. Okay. So an example might be f of x equals square root of x plus 4. All right. So if it's negative, it goes down. If it's positive, it goes up. So this one is not the opposite. So what that might look like on Desmos is if I have square root of x and then plus 4 on the outside, notice how my whole thing shifted up 4. If I have -1, then my whole graph shifts down 1. And I can have a combination of both. Maybe I want it to shift down and to the right. So maybe I have -1 underneath, that means it shifts to the right, and -1 on the outside, that means it shifts down. So you're going to have multiple things. And maybe I want a vertical stretch by 3, so I put a 3 out in front, so now it's getting stretched vertically. Okay? So these are our basic functions. So let's go ahead and try some that we can graph on our own. So let's say, really more like example 1, we have f of x equals 3 times the square root of x minus 3 plus 4. So what I would always suggest doing is start by finding your initial value. So where does it start? Okay, and that's always going to be where it shifts horizontally and vertically. So remember, this tells us it goes to the right 3, so it's going to be at x is 3, and then this tells us it's going to go up 4. So the point 3, 4 is going to be our starting point. So let's see, 1, 2, 3, 1, 2, 3, 4. Okay, so here's our starting point, and then I would just go ahead and make your table. You can still use the table of values that we did originally. So here's our x and our y, and if we plug in 0, 1, and 4, then if we're multiplying it by 3, so we're multiplying it by 3, so that means I'm going to take, remember my original values were 0, 1, and 2. Okay, that's just from the original parent function. But I'm multiplying all of these by 3, so this is going to stay as a 0. 1 times 3 gets us 3. 2 times 3 gets us 6. So I'm just taking this number here. This is what I multiply by. Okay, so what this means, and this is a shortcut to graphing pretty much, is that I can start at my original point, and what I'm going to do is I'm going to go to the left or to the right one and then up 3. So if I put 0, 0, then that doesn't really change anything. So I'm going to go to the right one and then up 3. So right 1 and then 1, 2, 3. Okay, and then I'm going to go from my starting point to the right 4. So let's see, 1, 2, 3, 4, and then up 6. So 1, 2, 3, 4, 5, 6. Right there. And now I can go ahead and connect my points. So these points that you're plotting here is just a shortcut to how you can graph. Now, if you don't like that shortcut and you just want to plug in points, that's perfectly fine. Whatever works best for you and I want you guys to be comfortable graphing. So if you like just plugging and chugging, by all means, go for it. But if you like the shortcut of just multiplying the number and that tells you how many to go over and up from the original point, then that's always a good way to do it. So let's try one more. I want you guys to try this one on your own. So example 2. This one says you have f of x equals negative and then x plus 2 to the 1/2 and then minus 3. Now, don't get thrown off by the to the 1/2 because remember, this is the same as f of x equals negative square root of x plus 2 minus 3. So it's the same thing, just different form, exponential versus radical form. So press the pause button, try to graph that one on your own, and then we'll check your answer here in a second. Okay, so I went ahead and set up basic examples. Make sure you're trying it on your own before you check with me. But right now I have my basic XY graph, and then I have my original table from our parent function. Now remember, we want to find our starting point. So our start point is where it shifts. So it's going to be at -2 because that x is a positive 2, and then it goes down 3. So -3. So we go to -2, -3. So there's our starting point. And then remember, the number out in front is what you multiply by in our table. So 0 times -1 is 0. 1 times -1 is -1. 2 times -1 is -2. So this means that I'm going to go to the right and down this time. So when I go to plot my points, from my original, I'm going to go over 1, down 1. So there's a point. And then from my original point, I'm going to go over 4, down 2. So 1, 2, 3, 4, down 2, like that. So this graph is very similar to your original function, except it's negative, so it's going down instead of up. Okay, and if we want to look at our domain and range, that doesn't hurt to look at because you might have those on your assignment. What's the smallest the x value can be? Okay, so let's do this again. The smallest, so the farthest to the left it's going to go, is -2. And does it hit at -2? Yes, so we can say it's equal. And then it goes on forever to the right, so we don't have anything that has to be less than. And then for our y values, what's the highest it can be, or the lowest? Well, the lowest is going to go, it keeps going down, okay, so it's going to go to -infinity in this case, so there's nothing to the left, but what's the highest it can go? Well, the highest it can go is at -3. So in this case, y is going to have to be less than or equal to -3. So you have to pay attention to the highs and lows. Does it keep going down forever, or does it keep going up forever? It's going to change depending on which direction the graph is going. Okay, so these are your square root functions. You're going to have to watch the next video for our cube root functions. Thanks for listening.